Hi everyone, welcome to video 2 for section 4.4 Inequalities in Two Variables. So the second part of your guided notes has three different example problems to work through. The first of these is going to be 2x plus y is less than or equal to 6. And hopefully before you're watching this video, before I actually get into the solutions, you've attempted these and given them a try, and now you're ready to double check your work to make sure that everything is good. So with this particular problem, so we have 2x plus y is less than or equal to 6. Again, there are a couple ways that you could have done this in order to graph it. I guess before we actually get into that, what I would want to note is that we have a less than or equal to sign. So this is different from the example worked on in the first video. So notice now, so this little bar underneath, this means less than or equal to. So you have a little bit more leeway here. So you basically will have a true statement if a number is less than another number, or if a number is equal to another number. So this is actually going to change the presentation of your answer when you go ahead and graph. So for this one, what I might start off with is saying, well, I might remove 2x from both sides. I'm going to get this into a slope-intercept form. This is just my choice. If you chose to do this by finding the x-intercept and the y-intercept, that of course would also be a great way of doing this. So now we're going to have y is less than or equal to negative 2x plus 6. So not too much work in order to get it into that slope-intercept form. So what I want to note here is that I do have a y-intercept at 6. So I'm about here. And again, I have a slope of negative 2. And if it helps, you can always write that 1 underneath it so that you can clearly see the rise and then the run. So in this case, we would go down 2, to the right 1. And we can continue in that fashion for however long, or you can go in the opposite direction. So instead of down 2 to the right 1, we can go up 2 to the left 1. And this time, because of that equal sign, we're going to go ahead and use a solid line through here. So that solid line is telling you I am allowed to use those points. They count as solutions in my work. So solid lines mean, yep, you can use it, you can see it, touch it, however you want to look at it. A dotted line, on the other hand, is basically saying it's there kind of as a boundary just to let you know, but you can't actually touch it or hold it or put it into the equation. So, for example, it looks like I have a point over here at 1, 4. So if I were to actually put that into my problem, so I'll do that work above here. So for a point 1, positive 4, I would put 1 in for x, and I would put 4 in for y, less than or equal to 6. We would get 2 plus 4 is less than or equal to 6. And then finish that out, and we would get 6 is less than or equal to 6. This is true. I mean, while 6 is not less than 6, so we would have concern if it was just this less than sign, we are okay to say that this is true because we have the option of saying or equal to. 6 is equal to 6. This is why we use that solid line in here, because we're saying you can use these values. So the next step would be, well, which side of the line do I shade? Do I pick the left or do I pick the right? And again, with this situation, I'm taking a look at this and saying, well, the origin isn't being used right now, so I'm going to use that as my tester. So using the origin, we'll put 0 in for x, 0 in for y, less than or equal to 6. 2 times 0 is 0, and then 0 is less than or equal to 6. Again, I get a true statement here, so that tells me that I'm good to shade on the left side. So Bear with me, the shading is not going to be stellar. But basically what you want to imagine is that you are filling in or shading this entire area all the way up to that solid line that you've drawn in. Again, all of your answers are over here on the left, and where we've left the right side blank, we're saying nothing's going to work over there, don't pick any of those points. So here is our solution. So let's move on to question 2. Okay. This one, again, is a little bit different. Okay. Notice that we don't have a y variable. And at this point, we don't want to just say, well, it's broken, I can't do this. If you kind of see the note that I have in the guided notes, what I want you to note here is just kind of, wow, I said note a lot, kind of imagine it with an equal sign. You've seen a problem like this before, and hopefully if you're kind of playing around with like maybe a table of values, you're saying, okay, this is saying x has to be 2. So no matter what points I'm picking, my y values can be anything, but my x values have to be 2. So I might come over here and say, well, if that's the case, then it looks like I'm actually creating a vertical line. The next question you want to ask yourself once you have those points down is this going to be a solid line, or is this going to be a dotted line? Well, the fact that you have an equal sign in your original problem tells you that this should be a solid line. The third step is, which way do I shade? And in this case, really, what I would encourage you to do is just take a look at the numbers on your x-axis. Which side has x values that are going to be less than or equal to 2? And hopefully, what you're noting or picking up on is, well, everything on the left is where all the x values are less than 2. So we've done a lot of questions that have used a less than symbol, and you're probably picking up on that theme, that it seems like anytime we have less than, we seem to be on the left side of the line. So let's go ahead and take a look at an example where it is greater than. Again, in this situation, what you might want to note is maybe try rewriting it with an equal sign, just to kind of bring back a certain level of familiarity if the inequality sign is kind of throwing you. If it's not, then don't feel the need to have to do this extra step. But again, what we want to note is if I were doing a table of values, this statement is saying I don't care what x values you use, but your y values have to be -4. So again, I can be ridiculous, or, you know, I could do 0, I could do 56, or I could just do something like 3. It doesn't matter what the x values are, as long as your y values are coming out to be -4. That's the instruction that you're being told. So in this case, we should be thinking, okay, this is an example of a horizontal line. And we would get that by maybe plotting some of these points. Can only really do 2. The middle one that I have is a little bit extravagant. The other thing to note, so you got your points down, the next thing that you should be asking yourself is, well, this just says greater than. Notice that there is no equal sign or no bar underneath the greater than symbol. So because of this, we're going to say, all right, I should use a dotted line in this case. I can't actually use any points that make up this line as part of my solutions, or else I'll get false statements. The next thing that we want to note is, again, specifically, the inequality sign. This is greater than. I need to find y values that are greater than -4 along this y-axis. So ask yourself, where would that happen? So are we going to see y values that are greater than -4 above? the line that we graphed, or are we going to see it below the line that we graphed? And hopefully what we're saying is, well, all these y values over here are going to be bigger than -4, so I should shade on this side of the line. Imagine that I've maybe filled this in a little bit better. But we're basically saying any point that I select over here, we're going to get true statements. I hope that these explanations have served you well. If you do have any questions, feel free to email me, note them for a discussion later. And yep, that's it. Go ahead and proceed to video 3.